Here's our second derivative on some applications with the power rule. So I'm going to be going over a little bit of what we talked about last time for review. And just so you remember, to find the second derivative, f double prime of x, you have to do the power rule twice. So let's start with a simple one, and I have a nice power rule function here, and it's a polynomial, excuse me, and now I want to do the derivative of it. So we're going to do f prime of x. 3 times 6 is going to be 18. Drop 1 on the power. 2 times negative 7 is negative 14. X to the first power, and then this is a 1, so, and it goes to x to the 0, so it's just going to be 5. And the derivative of negative 4 is going to be 0 because it's a constant. Now when I do f double prime of x, we're going to take the derivative of our first derivative. So 2 times 18 is 36. Drop 1 on the power is x. There's a little 1 there, minus 14. X to the 0, which is 1, or a 0. So there's just a quick review on how to do the first and second derivative. Now here's some basics again, what we talked about before, and we're looking for intervals for all of these, okay? So if we want to find intervals, what we usually do is we take our first and second derivatives and put them equal to 0, because that will show us the points where they change. So if f of x is increasing, our original function is an increase, so we're going to look at our first derivative, and if our first derivative is positive, then that's where it's increasing. If our first derivative is negative, that's where it's decreasing. Okay? If we want to talk about concavity, if I want to know when my original function is concave up or down, then what we're going to do is look at our second derivative, which is here. If it's positive, it's concave up like a cup. If it's negative, it's concave down like a frown. So that's just a quick review of what we talked about before. So let's practice this. And I have a nice function here. It's a polynomial. So let's review things we've learned before. It's a third degree, so I know it's going to have at least 3 roots, at most 3 roots. It's going to have 2 turns in my graph. It's going to have, my tails are going to be opposite because it's an odd function. And I know my right tail is going to be up because it's positive in front. So that's things we learned before. Now we want to talk about when is it increasing. Well, if this is increasing, we're going to do the first derivative has to be greater than 0. And if it's concave up, our second derivative also has to be greater than 0. So if they're both greater than 0, we're going to see where this function is increasing and it's concave up. So let's show some work here. So I have f prime of x, so we're going to do the first derivative, and I just hid the function a little bit, but 3 times 1/3 is going to be 1, so I have x squared, because I got to drop the power, okay, plus 2 times 2 is 4, drop the power, and the derivative of 5 is 0, so we're going to put it equal to 0. And then we're going to factor this so that we can find where the slopes are 0 on our graph, or turning points, I should say, or maxes and mins. So I have x equals 0 here, and x plus 4 equals 0. Please don't skip this step, so x equals negative 4. So these are our 2 x's where there's going to be turning points on our graph, or maxes and mins. Okay? And I'm going to graph this and get it all set up while we're talking here. So I'm going to make a nice graph here. And we'll sketch it. And you can always graph it and check it, and I want you to. And we'll set up our f prime bar here. And our f double prime bar right here. Okay, so we just found at 0 and at negative 4. Okay, so here's 0. Okay, and negative 4, we'll say 1, 2, 3. Negative 4 is here, so I come down here. So here's negative 4, and here's 0 on our graph. So this is going to be changing, and increasing and decreasing. So I want you to do what I showed you before. Go to the factored part, and we're going to go left of negative 4. So if I pick negative 5, that would be negative, and that would be negative. A negative times a negative is positive. Between negative 4 and 0, let's pick negative 1. Negative 1, and this would be a positive 3. Negative times a positive is negative. let's go greater than 0, so let's pick 1. 1 here, and 1 plus 4 is 5, so I have positive times a positive, so this is positive. What does this mean for our original function? Well, it's increasing, it's decreasing, and it's increasing. All right? The next thing is we want to look at concavity. So we have to do f double prime of x. So that's going to be 2 times x plus 4. This should be getting easier. Put that equal to 0. I'm going to solve for that. 2x equals negative 4. So x is going to equal negative 2. So right there is going to be our change in our concavity. So I'm going to put that on my graph. So here's negative 2. I'm going to come down here on my f double prime and put the negative 2. Now this is going to show the change in concavity, so we're going to go back to this to see where it's concave up and down. So if I go to the left of negative 2, we'll pick negative 3. If I put a negative 3 in there, it would be negative 6 plus 4, so this is going to be negative here. And if I go to the right of negative 2, let's pick 0 for example, this would be positive when I plug it in. I hope you see where I'm doing that. This shows that it's concave down, right here, and our original graph is concave up. So now we can kind of sketch it, and you can always graph it and check it to see what this graph would look like. And the graph kind of looks like this. So I know there's a turning point here at 0, and it looks kind of like this. So it's increasing, it comes to kind of a turning point here, then it goes down, and at 0 it kind of goes up like this. So if you'll see, our slope is 0 right here at negative 4, and at 0, and at negative 2, the concavities from concave up down to concave up is right at negative 2. Now they want us to find when it's increasing and concave up. So this function is increasing here and here, and it's concave up from here to here. So where does it do both? Well, it goes from 0 on up is where it's increasing and concave up. So our answer is when x is greater than 0, or I like interval notation 0 to infinity. So that's our answer for this one. That tells us when this graph is increasing and concave up. All right? Let's try another example. On which intervals is this both increasing and concave down? So let's set this up. F prime of x has got to be greater than 0, and f double prime of x has to be less than 0 because I want it to be concave down. Now if you want to stop this and see how good you do, that's fine, and then come back. I'm going to continue on to show you how this works. All right? So I'm going to do the first derivative, put it equal to 0. 3x squared minus 4x minus 7 equals 0. And when I factor this, I have 3x minus 7 and, excuse me, x plus 1. Okay, make a big T here. So I have 3x minus 7 equals 0, x plus 1 equals 0, 3x equals 7, x equals 7/3. I'm going to box that. X is going to equal negative 1, and I box that. So again, these are the two places where they have a slope of 0, which is going to help our intervals. So let's draw the picture. I like doing it right along when I'm doing this. So I get my graph all set up here, nice and big, bigger than your pinky, I always say. So I have x and y, and I get my f prime bar going here, and my f double prime bar, so that we can see how to do this. Okay, so I got x is 7/3, so that's going to be about 7/3 is a little over 2. So 7/3 is going to be about right here somewhere. All right, and the other one is negative 1, so that's about here somewhere. So we set that up. Now let's figure out where this is increasing and decreasing. So let's go to the left of negative 1. So if I do is pick negative 2. So if I put a negative 2 in there, that'd be negative 6 minus 7. So that's negative. That's negative. A negative times a negative is a positive. Let's go between negative 1 and 7/3. Let's pick 0 because that's easy. So 0 would make this negative. So remember, I'm going back to the factored form and plugging it in and just looking at the signs. So if I put a 0 in here, this is negative. And if I put a 0, that's positive. Negative times positive is negative. Now if I go greater than 7/3, let's pick 3. This would be positive. That'd be 9 minus 7, and that'd be positive. So this is positive. That means my function is going to be increasing, decreasing, and increasing. Okay, now let's do the second derivative to see about the concavity. So that would be 6x minus 4. 6x equals 4. X equals 2/3. So I just found where this changes concavity is at x equals 2/3. And 2/3 is going to be about right in here. Okay, so let's go to the left and right. So we're going to go back to this and plug in some numbers to see what's happening with the concavity. So the left of 2/3 we'll say is 0. So that would be a negative. To the right of 2/3, let's pick 2, for example. That would be positive. So this shows that it's concave down here. And then it's going to be concave up here. So we can kind of sketch this graph, and you can see how it looks when you graph it. So it's going to be increasing, and then it's going to have at -1 like a turning point. It's going to be decreasing until about 7/3, where there's another slope of 0. Then it's going to be increasing. Okay, and we did show that it's going to be, the tail's going to be up. It's because it's positive. It's got 2 turns, and at least it's going to have 3 roots, at most, excuse me. So the question is, when is it increasing? So let me highlight it. When's it increasing? It's increasing here and here, and it's got to be concave down, so that's here. So where is it both? Well, it's from when x is less than -1. Here, let me put this in a better spot. My answer is going to be when x is less than -1, or I can say negative infinity all the way up to -1. And I note I never include the actual turning point because that's where the slope is 0, so you don't want to include that. All right, we have one more for practice for applications, and this one's a short one, and we're going to discuss this more in class, but I have this function. It's another third power polynomial, third degree polynomial, and basically it says find all the values for which f prime of x equals 0. This question is actually simpler than the ones we just did, and it only has one step. So basically we're just going to do f prime of x and put it equal to 0. So that's going to be 6x squared plus 12x minus 18. And we're going to put that equal to 0. I'm going to factor out the 6. And then factor it some more. So I have x plus 3, x minus 1. Make a big T here. So 6 will never equal 0, so thanks for playing. X plus 3 equals 0, x equals -3. And x minus 1 equals 0, or x equals 1. So what did we find here? What does this mean? Okay, so again we talk about this. What does this mean? That you found the places on the graph, the x value, that you're going to have either maxes or mins, turning points if you will, and then you can find in between these intervals when it increases and decreases. Well, that concludes some more practice on power rule applications.